Okay, so let's imagine what we're seeing. So we have something inside of a field of view. What is our field of view? I don't know. Micrometers. Okay. So we have something that takes up about one of 2.5, right? So let's see. Maybe it's like this big. And then we'll say that's 2.5. So we have an organism that takes up 2.5. Now it's weird to have like a decimal and a fraction of this diameter, field of view. So what's the first thing we have to do? Multiply. So we do 95.78 micrometers times what?
1 over 2.5.
1 over 2.5. I don't know that answer. What is that answer?
38.3. Did it all by myself.
38.31 what? Nope.
Millimeters.
If we start with 2 decimal places, you keep 2 decimal places. We'll go over those rules at a different. Okay, but what do I want my answer in? Equals how many millimeters? So point. Okay, why did you do that? We moved our decimal which way? To the left, because this time we're going from micrometers to millimeters. You're going millimeters to micrometers, you go to the right. Micrometers to millimeters, you go to the left. So 1, 2, 3. And it'd be 0.038. But actually, 2 decimal places, we keep 2 decimal places, so it'll be 0. Don't worry on a test. I haven't literally taught you that rule yet, so actually we did kind of go over it. Kind of. We went over when you're looking at a ruler, you have limits on your decimal place, right? There's more rules when you're multiplying and dividing with significant figures, what you can do. So on a test, if you put 0.03831, you would be okay. Okay, so about the test. I decided we are not going to be ready by tomorrow. Do you feel the same? Okay. About your test, we are going to basically have 3 written response questions. I might throw in a couple of multiple choice. But this test is basically going to be 3 written response math questions. You will have a calculator. I cannot let you use your phone. So if you bring a calculator to class, that'd be great. If not, I have a few extra. The test will be Tuesday. You'll have the weekend to study. And the 3 questions, one of them we practiced with, right? One of them is going to be what you did on the microscope, looking at an organism, estimating the size of the organism given your field of view. Okay, so you have that 2 examples in your notes, the one with the pig nose and the other one. So one question will be like that. The other 2 questions will be what we're going to go over today. We're going to spend basically all day on that practice, and then we'll review it tomorrow. The third main component of Unit 2 is drawing organisms. So I am not going to put that on the test. That'll be more like kind of a project. Okay. So tomorrow and Tuesday, you guys will get on a microscope and you're actually going to draw. Remember yesterday we went over the rules of drawing. You have to have horizontal lines, a specific title, scale bar. Basically, you're going to do that and you're going to turn that in for credit. It won't necessarily be a test because I'll be there to guide you. But you are going to do that and turn it in, okay, as points. Okay, so I also sent a reminder out yesterday that I decided to change the due date of the syllabus statement. I should have sent it out sooner, but I got really tired yesterday, so I'm sorry about that. If you did your syllabus statement, awesome, you're ahead. If you didn't because you had no idea what to do yet, you'll have some time. Yes. Yes, the Brush with Nature, I would still like to be due on the 5th. And the good thing is you have the 3-day weekend to work on it, right? And so you should be bringing it to school Monday. It should be done on Sunday to be turned in, sorry, on Tuesday. It should be, yes. So if you have it done by Tuesday morning, you'll be fine, okay? I was gonna do video, but I actually found a different website you can look at for, if you haven't started yet, some inspiration. Oh, does anybody have progress reports? I'll take it. There's a pile right there. This just kind of has some images. So if you haven't started yet on your Brush with Nature, I'm getting a little nervous. Okay, but you do have a 3-day weekend. So here is some pollen. Pollen is kind of a fun thing to draw, especially if you like geometric shapes. I had questions about coloring. Do you have to color it?
Yeah.
It's up to you, especially because most SEMs come out like this. Even this pollen started black and white, and then it was edited with color. Okay, so you can color it or you can not color it. It is up to you. This is an art project, so it should be kind of like a realism art project, right? But you can color it if you think it needs color. Here is what is this? Trachea epithelium. What is your trachea?
Fingertip, bro.
Your fingertips. Your throat, also known as your windpipe. So yes, you have these hairs in your windpipe. What they will do is they will catch things that you breathe in that your body doesn't want. And when you cough, it's because those caught something and it told your body, cough it back out. You don't want that in your body. There's lots of insects that are fun to draw. So this is a leaf beetle. I had somebody ask me, can I trace? I have seen people do that. You put your paper up and you trace. I am okay with that. I would not consider that cheating. In fact, that would probably be what I would do because I'm terrible at drawing. Yes. Yeah. I don't know. I think there's just something about the sun has affected your nervous system, and your nervous system is like sneeze. Also, I think it might be an evolutionary thing, an evolutionary trait, because if you look at the sun too long, you'll burn your eyeballs. So your body has found a way to force you to close your eyes by sneezing. I don't know exactly the mechanism, but I would think that's maybe our body going like, don't do that. So I'm going to make you sneeze, but I will force you to close your eyes. That's a good question. Fruit fly. I think this is an amazing picture, especially if you're not great at drawing and like drawing this stresses you out because there's too much. Maybe drawing this is a lot easier. Okay. So that's kind of cool. And then you would just have to draw a fruit fly, which could be fun. Here's a mite. This is a bed bug. Notice its long sucker. I don't know. This is a kidney stone. No wonder they hurt so much. Yeah. So the kidney stone, I would say, is not a living thing, but it affects living things. I don't know how you would draw a kidney stone zoomed out. I mean, I guess you could find an image of one. It wouldn't be too exciting zoomed out, but it's kind of interesting zoomed out. This is Yersinia pestis, the causative agent of the bubonic plague on the spines of a flea. Here you go. White blood cell eating methicillin-resistant Staphylococcus aureus. MRSA. MRSA is a terrible thing. If you have people who work in hospital settings, you could ask them, hey, have you heard of MRSA? And they'll probably be able to tell you about it. It's a really bad infection. Hard to combat. Salmonella, Typhimurium invading human cells. Here is a HeLa cell undergoing programmed cell death, apoptosis. Here is algae. That's kind of fun. That's kind of fun. I mean, it wouldn't be super exciting zoomed out, but it's pretty exciting zoomed in. SEM. The water bear is so cute. There's lots of other pictures. And that's it. So this source, I'll actually link it on our agenda, SEM images. So that's what you want to look up. If you want to look up like tarantula SEM, okay? I'll put this on, thank you, Rick. I'll put this on our daily agenda. If you like those images and you want to use them, they'll be down here. Bye, see you at lunch. No, that was just practice. I would keep it to study, actually. Okay, we are in our notes. We are on this page. Yeah, I just wanted to like. I'm also partially checking. Did you guys get all your boxes filled out, especially those of you who are on microscope?
Yeah.
If you didn't get these boxes filled out, you need to take a picture of someone and fill it out. Okay. Same thing, Malia, take a picture.
You need to get when you Sorry,
If you don't have that written, write it. It's on the screen.
Oh,
I know. Go, 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 go.
so sorry.
What are you thinking? Come on. We got things to do. Micrograph is a photograph taken through a microscope to show a magnified image of an item. Some of you guys, I know, even showed me on your phone that you took a micrograph, which is exciting. If you didn't, that's okay. But you will have another chance when we do our drawings. I always just find it fascinating to be able to take a picture through a microscope. So basically all these pictures we've been looking at are all micrographs, okay? The only thing that is not a micrograph would be a drawing. Okay, if you draw, not a micrograph, it's a drawing, okay? All right. Moving on. Almost.
Yeah.
There you go. Okay. So it says our next thing is to state why the magnification of a drawing or micrograph is not the same as the magnification of the microscope. Well, the simple thing is because if you're drawing something from a microscope, how big does your drawing have to be on a paper?
Microscopic.
We had a rule that we drew yesterday. On the paper, it should take up about how much? About half of a paper, right? So that's obviously bigger than in what you're seeing under the microscope. So that's kind of the short answer. So I think under at the very bottom of that page, just we draw structures much larger than the size we see them under a microscope. First sentence is fine. Very bottom. Where it says illustrate the differences between. No, you're just writing this first sentence. We draw structures much larger than the size we see them when viewed under a microscope. So obviously we're drawing microscopic things. So obviously we're drawing it bigger than real life, but we're also even drawing it bigger than the magnification in the microscope. You want to draw it in a nice large size. So what we will practice with today is when we have drawings, we need to put a scale bar. Because when somebody's looking at this drawing, they want to know how big is that organism in real life? It's a paramecium that has very little detail. This is the oral groove right here. I would definitely say this is an unfinished drawing. Right? But the reason we put a scale bar is so we know that we can calculate how big that paramecium really is. I know we don't really look at maps anymore, like other than Google Maps, like an actual map. But if you ever looked at an actual map, there's a scale bar, right? So if you're driving from California to Arizona, which might be 3 inches on a map, obviously you're not driving 3 inches, right? But with the scale bar, you can calculate how many actual miles that is. This is something we used to have to do. Now we just Google map it and it tells us. Very nice. When I was in high school, there was no Google Maps. There was maps, but there wasn't like an app where it was like in-time driving. So anytime I would go to like a party or Disneyland or somewhere, we would go on the computer, get the directions, print out the directions, and we'd have like a packet of directions. And you would follow the direction. And if you missed one, good luck figuring out where to go. It was terrible. So I would, whoever was in the passenger seat would be looking at the paper and like, okay, like looking for the street, like turn right on this street. And then you got to like make sure you don't miss it. And if you missed it, there was no rerouting function. There was just like, don't mess up. It was very stressful, actually. I always like to be the driver because then I could yell at the person who messed up rather than being the person who messed up. Anyways, okay. So we have some practices in your packet, and I actually have a whole packet of practice for you here, which you should say, yay, we have plenty of practice to prepare us for the test. Okay. The math is easy. Remembering conceptually how to do it and remembering your equations, the trick part. So if you want to actually look at both of the next pages together, I want to show you the difference in what we're doing. Okay. The first page says you can find the drawing magnification if you have the measured size of the drawing and the size of the specimen. Okay. So of these 3 pieces of information, you need at least 2 of them. Look to the next page. The next page, we should be able to find the size of the specimen if we are given the measured size of the drawing, which if you have a ruler, you can do, and the drawing magnification. So these are kind of similar because the equations are similar, right? But different. So on your practice, not on your test. So the first thing we will find is how big is our drawing magnification? You can always find the measured size of the drawing because you will have a ruler. The size of the specimen will have to be given to you. Okay? So, see here. Since you are calculating magnification from an estimate, you must round your answer to one significant digit. The size of the specimen, we're going to have to use what we did previously in our do now. Okay? Or it'll give it to us. In this case, it's going to give it to us. Probably on your test, they'll give it to you too. Okay. Here is a drawing of a 200 micrometer cell viewed under the microscope at high power. Calculate the magnification of the drawing. Okay. So do we have our 2 pieces of information that we need? Do we have the measured size of the drawing? Yes. Yes, from the ruler. We're going to do the length. Okay. Do we have the size of the specimen?
Yeah.
Good. All right. Go ahead. But it is saying that we want our answer in. Okay. So we have. Okay. This could be a tricky part. It's telling us that our organism is in micrometers. What is our ruler in? Millimeters. You always need to make sure you're working with the same units, right? So first thing we need to do is figure out how many micrometers is the drawing. Okay, so we're at 54 millimeters. That is not micrometers. 54 millimeters is how many go to the right 3 times.
54,000.
Okay.
Yeah.
So, number 1, we should have the answer written for number 1 as 54,000 micrometers. Okay. Now we use the equation. For today, you can use your phone. On a test, you need a calculator.
27.
Okay, let's check that answer. The measured size of the drawing is 54,000 micrometers. Always, always,
Never
always
mind.
show your units, in
Not
your
this.
work, in your answer, in everything. Divided by 200 micrometers, good. So we can start by just canceling some zeros. So 540 divided by 2, 27.
270.
There we go. Sorry, sometimes when you all say the answer, I'm like, what?
Yeah, Malia.
270. This, what are we finding? We're finding the drawing magnification, right? So actually our units cancel too. So 270, what do we write? It's not technically a unit, but what symbol do we use to represent magnification? X. So 270x. That means that we drew this 270 times larger in real life. Cool. All right. Now, practice problem number 2 gets more difficult because look what we have to do. We have to use our do now warm-up information to get the size of the organism. And then we use that in the equation. Okay? So, all right, so I should have been doing this on the board. So first we did 54 millimeters converted to 54,000 micrometers. We put that in our equation and we got our answer. Oh, I forgot that part. We have to round to one significant digit. So I'm sorry, go back to your answer, number 3. So for number 2, you should have 270x. Number 3, you need to round to one significant digit, 300x.
Why is that significant?
So let me go back to the slide that explained that. I don't know why this isn't like. Okay. So since you are calculating magnification from an estimate, our measured size of the drawing, our size of the specimen is already an estimate, right? Because we got that by drawing circles and estimating how much of the field of view it would take up. So basically, we can't be sure that it's 270x. We can't be that confident because we're calculating based on an estimate. So what we have to do is we have to go, okay, I'm not quite that confident, but it rounds to about 300. So that's how confident I could be. Also, this is just saying, make sure you're always in the same units. Okay. So that third part, you always just round to one significant figure. I know you guys know how to round, but that's why. Okay, here we go. Practice problem number 2. Use the diagrams to answer the following questions. First step, we need to figure out what is the estimated size of the cell. We did this not last week, but the last couple of days. So go ahead. I want you guys to see if you can do that. Okay, I'm going to give you a couple minutes to see if you can figure out at least number 1, number 2, and number 3. Okay. So you have the information you need. You have the field of view at low power. You have your low power mag. You have your high power mag. You can do that. We just did that last couple of days. So figure out the first bullet point, the first 1, 2, 3. See if you can remember the formula without looking it up, but if you can't, look it up. guys get readathon stuff yet?
No.
No, because I think I'm supposed to give it to you. Okay. They didn't tell us specifically, like, pass this out to your first period. I'm just gonna give it to you. Most high schoolers honestly don't do it, so I'm not gonna waste our time talking about it. You read and win prizes. But right now, what's more important is your IB grade for your test. So focus on that. I don't know, actually, you have to read the instructions. I mean, no. It starts September 1st. If you're talking about the math. And if you feel like you want to go on to the second bullet point, I won't stop. Yeah, do like a widest width. Yeah, and I know it's not lined up, so you're gonna have to do some math. On your test, you're gonna just actually be using your own ruler, so you won't have to do the subtraction. Remember, if you're close to my numbers, you're on the right track. You might have a slightly different number, but I'll be there. What is it?
Oh yeah, I don't know why I'm asking. Wait, no, that's not even 2.5. That's 2.1.
Don't worry, on your test, you're gonna use your own ruler. So you'll just find that. Yes. About to go over this, which would be really good to see. And then you can go. Can you hold it just that long? Okay. Okay. So what's our first step? We need to first determine the size of the field of view using the higher power magnification. So we have an equation. What's the equation to figure out our size of the field of view at high mag? Okay, low power stuff divided by high power stuff, right? Low power diameter times low power mag, good. Over high power mag, very good. Okay, so what's our low power diameter? Right here. 1, 2, 3 point. I would say 6. Because 5 would be half of that space.
I agree.
Let's see what I said in my notes. I said 3.5. Okay, we'll go 3.5. Remember, on a test, if you're 0.1 or 2 or even 0.3 off, as long as you did the math correctly, you're fine. Okay, so we're gonna go with 3.5 times, wait, 3.5 what? Millimeters, good, times 40x, good, divided by 1,000. Okay, what's 3.5 times 40? 3.5 times 40? 140 divided by 1,000. 0.14 millimeters. Wonderful. So that should be your answer for number 1. Under practice problem number 2. Okay, so we've gotten our field of view at high power. Wonderful. Now we use that to figure out the size, the estimated size of our cell. Okay, so I'm going to go back to this image. Here's our cell. We need to figure out about how many of those cells would fit in our circle. 1.2. Does anybody want to argue with that answer? 1.4? Okay, let's see what I said in my notes. I said 2/3. That's a different.
That is 0.6.
I did it a different way. That's okay. So we want to go with, I heard 1.2 and 1.4. 1.3? Let's do 1.3. Okay. So we would say that 1 out of 1.3 is what we want, right? If 1.3 fits, we only want to measure 1 of those 1.3. So we're measuring we're multiplying 1 over 1.3 times what? 0.14 millimeters. Okay, what is that? 0.14 divided by 1.3. Ready? 0.1. Is that what you got, Mark? Oh. If you were on your phone, what were you doing? Oh. 0.10? We'll round at the end. Right now, what is it? Give me the whole thing. Okay, so we're gonna do, if we started with 2 decimal places, we're gonna do 2 decimal places. So 0.11. Okay. Okay, so 0.11 millimeters would be the size, the estimated size of our specimen. So that would be your answer for number 2. Sorry, number 2 is 1 over 1.3. And then number 3 is our answer. There's number 1. Here's number 2. And here's number 3. For your notes. Okay. Is that close to what I got? 0.09. Okay, close enough. So now that we know the estimated size of the cell, now we can use that information to figure out the drawing magnification. So measure the size of the drawing. 8 cm?
I got 7.
7?
7.7.
7.7? All right, so we're gonna do like a 9 point, what?
9.8.
Yeah, I know, I'm gonna do subtraction. 9 point.
It does not start at.
It
It does not start at. It starts at 2.1.
9.8.
Each one is 0.2, right? 9.2, 4, 6, 8, 10. So 9.2, 4, 6, 7. I'm gonna do 9.7 minus.
Why are we doing centimeters?
Why are, I don't, what?
We'll convert. 9.7 minus 2. I'm gonna do the widest width. 2.1. It's 9.7 minus 2.1.
Cool.
Remember, if you were close, you're fine. 9.7, 2.1, 7.6. Were you close to 7.6? Ballpark. Okay. So we have 7.6 what? Meters. But what do we want it to be in? Millimeters. All right. How do we go from centimeters to millimeters?
Don't we do like 1
A decimal to the right.
Yes.
All the conversion.
I think I'll just stick you guys with millimeters and micrometers. Okay, just remember the one. Millimeters, micrometers, 3.
7.6.
I apologize for my grading. Should be better when I get back, or not, I don't know. It might not be. It should be better next year. Okay, so number 1, we measured and converted to millimeters. We have 7.6 millimeters, yes? Now we use our equation. 76 millimeters. That's number 1, right?
What's the drawing then?
Drawing magnification is on there somewhere, isn't it? Okay, here's the equation. We don't know the drawing magnification. We know the measured size of the drawing, which was measured size of the drawing was 76 millimeters. Okay, and then we do the size of the specimen, which was
0.11.
0.11 millimeters. We're almost there. And what is that? Calculator people, go.
Nine 0.90.
690.90. We agree? Okay. So that, wait, what do I have on the end? Simple.
Millimeter. Yo, believe me.
Our millimeters cancel. Hey,
Micro-
very good.
Oh.
I'm very smart.
All right, so we would say that our drawing is about 690.9 times bigger, but we can't be that confident. So we round to 700x. That's number 2 is using your equation. Number 3 is rounding to 1 significant. I know that was very long. All right. Is it? You can press down. Can you press down? IBY1 70 degrees. Oh, last time I asked somebody to press down, they went down to 63. And I was freezing. I was like, why am I freezing? Okay, so practice problem number 3. Now we're switching it up. By the way, I'm thinking practice problem number 2 with all the steps together. I might make that a 4th extra credit problem because that's a lot to do like all in one. So I'm thinking I might make like the beginning of that one question and then like practice problem number 1, that'll be another question. Okay, because the one we just did was like putting it all together is a lot. But I might put that as an extra credit question because I know you guys like chances for extra. Practice problem number 3 is different. This was another practice. We might go through that tomorrow. So this one, we are looking, given the drawing, this one's actually much easier. Given the drawing magnification and given the measured size of the drawing, we need to figure out the size of the specimen. So this one's saying, we know how much bigger it is. So what's the real life size? Okay. So we are going to start by having this amoeba. Look how cute it is. It's eating something. Here's an amoeba drawn at 200 times life size. What is the actual size of the amoeba? So again, I know your ruler is not lined up necessarily, but we're going to figure out what is the measured size of the drawing. All right, we got one answer. Want to dispute that answer?
I said 18.
It's 17. Thank you.
I'm going to go here. 18 minus 18 minus 1. Yeah, let's do that. Okay, good.
Yeah.
So our measured size of the drawing, I put 17.1, that's fine. 17 is good. 17 centimeters. So this is something we were doing in biotech, and some people seem to be struggling with the difference between a centimeter and a millimeter on your ruler. That is something you guys need to have figured out. Okay? Make sure you guys know how to measure a centimeter versus how to measure a millimeter. Okay. So we have 17, you can go 17. 17 centimeters. We want to convert that to millimeters. 170. Very good. So converting that to millimeters, 170. If you want to go with the notes, you can do 170. Okay, easy enough, right? That's the easy part. Then we use the formula. 170 over 200 because it told us that our drawing is 200 times life size. Okay, so 170. Why did I do 176? That's weird. That's wrong. Let me fix that. 171, if we're doing that. Divided by 200x gives you 0.88 millimeters. I don't know. 0.85. Finally, round your specimen size estimation to one significant digit. So one significant digit would be to the tens place, so it'd be 0.9 millimeters. And if you want, you can convert millimeters to micrometers. On a test, I will say, I want the answer in millimeters or micrometers. So it'll be clear what I want. Okay. 0.85 would also be 0.9. Yeah. All right. Much easier, this one, right? Practice problem number 2 was big. Oh, look, here's a radiolarian. It's a part of the ocean microorganisms, I think. Okay. Ooh, that's actually the end of our slideshow. Woo! Instead of doing this one, I actually have paper practice that I want us to do. Can I get somebody to pass out? Maybe 2 people, so it goes faster. This is the part I suggest you have a pencil, because if you mess up, you can erase. And a calculator. I know not all of you guys have a calculator, so get a calculator. I am gonna end the recording now. So if you are watching this recording, we're just doing extra practice on paper. You can use your phone as a calculator. All right, so end recording.